Good morning. Today we're going to start Module 10, which is entitled Diet, Physical Activity, and Obesity, and we're going to spend some particular time emphasizing the role of physical activity and diet in weight loss and weight maintenance. So just to review obesity, I'm sure you're familiar with this term, but obesity means simply excess body fat. Usually the definition comes from a BMI, which is a body mass index of greater than 30. You can calculate your BMI by dividing your weight in kilograms by your height in meters squared, or you can go online and find a very easy to use BMI calculator that will allow you to enter your weight and height in more familiar terms. However, BMI doesn't actually assess the amount of fat. So you can see the problem with using BMI to assess obesity, which is defined as excess body fat. BMI simply accounts for your height and your weight. And so most people that have a high BMI do have excess body fat. But the other scenario where you could have a high BMI but not be obese is when you have a lot of muscle mass. And so particularly for an athletic population, BMI is not very useful. However, when we talk about assessing the general population, BMI is pretty appropriate to do. And so all of the CDC charts that you see, most of the main assessment methods for obesity, when we're looking at the population, they use BMI. However, to actually assess body fat, there are a number of other assessment techniques. They're more invasive, more time-consuming. They involve actually dealing with the physical person. BMI, you could ask someone over the phone, what's your height and what's your weight? These other techniques, you require face-to-face contact with the individual. These are skin fold, bod pod. This is the picture you see in the upper right-hand corner is a bod pod. What it does is it measures air displacement. So someone who takes up more space has more body mass, and then there are formulas that can be used to estimate percent body fat based on that. The technique is really very similar to water displacement. This is called hydrostatic weighing, but air displacement is a little bit more user-friendly. For instance, it's very hard to do hydrostatic weighing with children or people who are uncomfortable or unfamiliar with water. Then we also have techniques called bioelectric impedance. This is a technique that sends a very small electrical signal through the body and then measures the resistance to that signal. Fat is more resistant than muscle, and so based on that principle can estimate percent body fat. And then probably the most precise measure is seen here. This is a DEXA, dual X-ray absorptiometry, and this is a technique that actually allows you to separate bone mass from muscle mass from fat mass, and it's a very, very precise measure of percent body fat. There's still a little bit of error, but not much. And this technique was originally used for assessing bone density. It's still used for that, but it can also do a very good job of giving an estimate of body composition. There's a person being scanned in a DEXA scanner. The device here is a bioelectric impedance handheld device. You just hold this device. It'll send an electrical current through your body. You won't feel it. It's very, very small. So how does somebody become overweight or obese? In one sense, it's very, very simple. There's more energy in than energy out. So energy in is food. It's what we consume. Proteins, fats or lipids, carbohydrates. Energy out is the calories that we burn. This comes from our resting metabolic rate, our physical activity, and what's called thermic effect of feeding or thermic effect of a meal. And this is the basically the energy cost of metabolism. It costs your body calories. Your body burns calories breaking down the food that you eat, and that's the thermic effect of feeding. So if those two things are balanced, energy in and energy out, you maintain your weight. If you have more energy coming in, you gain weight. If you have more energy going out, you lose weight. But of course, it's not that simple, because obesity has all kinds of genetic factors, behavioral factors, environmental factors, psychological, hormonal, diet, physical activity. Those are all very social and cultural. And so it's easy to say, well, just eat fewer calories, be more active, but it's typically much, much more complex than that. So in the United States, here's a few statistics. The prevalence of obesity has dramatically increased since the 70s. You're probably all aware of that. About 1/3 of the United States men and women are obese, 31% of men and 33% of women. And about 2/3 are classified as either overweight or obese. Overweight is a BMI greater than 25, but not 30. 30 is obese. So 71% of men, 62% of women. Prevalence is also increasing in children. And then the average adult gains 1 to 2 pounds per year after the age of 25. So that may seem like a fairly small amount, but of course after 10 years, if you've gained 10 to 20 pounds, and after 30 years you gained 30 to 60 pounds, then you can see where obesity is a problem. I pulled this straight off of the CDC website. You can go log in anytime and get this information. It is the most recent, the 2014 is the most recent they have uploaded so far. Statistics, you can get each individual state. What you see here is Alabama, but you can also get the nationwide data. So in Alabama, you can see that 33.5% of their sample, which had 8,190 people in it, in the year 2014, they were classified as obese, and you can even see where the data came from, the BRFSS. And if you remember back to earlier in this semester, that's the survey where they call people on the phone and do an interview about health-related behaviors. And so they would have asked, what's your height, what's your weight, and that's where that information came from. So you can see about 1/3 of Alabamans, according to the BRFSS data, are obese, and about another 1/3 are overweight. And then there's all kinds of information. Adolescents who are obese, adolescents who are overweight, 2 to 4 year olds on WIC, which is an assistance program for low-income mothers and children. So they're federally tracked. That data is available. And so around 15% of 2 to 4 year olds are obese, and another 16% are overweight. And again, you can get this information for any state and the nation as a whole. Here is the most recent obesity map published by the CDC. This is from BRFSS data in 2015. And what you see is the green colors are the lower percentages of obesity. So if, for instance, let's look at Montana. Montana is coded as green. This green means 20 to 25% of the population is self-reported obese. So that means that according to the height and weight that they self-reported when they were called for the survey for BRFSS, they gave numbers that put them at a BMI greater than 30. If you look at Alabama and the red states, that means that the population reported greater than 35% of the population reported being obese. So, of course, that's very alarming. Here's just some key information from that BRFSS data nationwide. So no state had a prevalence of obesity less than 20%. 6 states in DC had a prevalence between 20 and 25%. 19 states and Puerto Rico had a prevalence between 25 and 30%. 21 states and Guam had a prevalence of 30 to 35%, and then 4 states of which we are, of course, included, Alabama, Louisiana, Mississippi, and West Virginia had a prevalence of obesity of 35% or higher. So the question is, what can we do about this, and how is body weight controlled? So it appears that body weight is regulated around what's called a set point, meaning that the body wants to maintain whatever weight it's at. It likes a certain weight, and it wants to maintain it. It's kind of like a thermostat. If you think about a house or an apartment, if you set the thermostat on 70 degrees and the temperature outside is 85 degrees, what's going to happen? The air conditioner is going to kick in, and it's going to bring the internal temperature down to 70 degrees, to what you've set it at. If you set your thermostat at 70 degrees and it's 40 degrees outside, the heater's going to kick on to bring that internal temperature up. So the thermostat is the set point, and it's kind of the same idea. Your body wants to maintain a certain weight, and so if you're consuming a lot of calories for whatever reason, you may become increasingly physically active, or you may stop consuming those extra calories. If you lose weight for whatever reason, then you may feel more hungry, consume more food, all in order to push your body to this set point. This is a bit of a theory, it's a little bit controversial, but there is quite a bit of research suggesting that this is how the body seems to work. So there's 3 components that make up the energy that we expend. The first is the resting metabolic rate. You'll see it abbreviated RMR, or sometimes you'll see basal metabolic rate, BMR. These mean the same thing essentially. We're going to consider them equal. This is the number of calories that your body needs to stay alive. If you laid on the couch and did nothing all day, you never moved, you would still burn a fairly large number of calories. It's about 60 to 75% of your daily energy expenditure. And then the thermic effect of a meal, or thermic effect of feeding, is the energy you expend for digesting, transporting, and metabolizing the food that you eat. So this is about 10% of your daily energy expenditure. So if you consume a 2,000 calorie diet, about 2,000 of those calories are going to be used to break down that food. Then thermic effect of activity. This is the energy above your resting metabolic rate that you need to perform activities. So whether that's walking, running, jumping, hopping, whatever it is, that's going to be additional energy expended. And this, of course, depends widely on your physical activity level. People who are more active are going to expend more calories. But between 15 and 30% of your daily energy expenditure comes from the thermic effect of activity. And of course, the one of these that's the easiest to change is activity. You can increase activity relatively easily. I'm sure you're all aware that there are health risks associated with obesity, but I want to define what some of these are. So heart disease, coronary heart disease, more generally cardiovascular disease, hypertension, which is high blood pressure, type 2 diabetes, which we're going to talk about next week, certain types of cancer, especially breast cancer and colon cancer, gallbladder disease, and osteoarthritis. And then obesity also results in a number of changes to normal body function that can be problematic. These include respiratory problems like sleep apnea. This is when you stop breathing while you're sleeping for at least a few seconds, and it's highly associated with obesity. It can be very problematic. Polycythemia. This is what happens. It basically means your blood becomes thicker or more viscous. This is because your body increases red blood cell production. And we know that red blood cells carry oxygen, so that may sound like a good thing. But thick blood, if you think of it like syrup almost, really thick blood can't flow very well, and so that actually causes problems with the heart. You're more likely to develop blood clots. Organs can become enlarged. This is especially a problem if it's your heart. You congestive heart failure, and decreased exercise tolerance, which of course then, if you're not exercising. So this really leads us to this issue of weight loss. People who are obese, there are a lot of them in this country. What do we do about it? How do we help them lose weight? Of course, preventing obesity is important as well, but today I want to talk about how to help people lose weight. So this data shows typical weight loss with a low-calorie diet. Most individuals try to lose weight by dieting or by changing what they eat. So there are 3 types of weight loss programs. Self-help, which is just people did whatever they wanted on their own, whatever they thought. Commercial, which was Weight Watchers. Weight Watchers is based on this idea that you consume food with an associated point. So a taco might have 5 points, and rice might have 3 points, and beans might have 2 points, and you can eat a certain number of points over the course of the day. So it's just a way to help people keep track of what it is that they're eating and how many calories it has. And then the other study was a placebo plus lifestyle. They took a pill that they thought was helping them lose weight, but it was actually a placebo, and then they were supposed to watch what they ate and be physically active. So you can see that in all of these studies, the participants lost weight. The scale is in kilograms, so 2.2 kilograms per pound. So this group, the self-help group, lost about 5 pounds. These groups lost between 12 and 15 pounds. But as you can see with all of them, they eventually regained at least some of the weight. And so that's a big problem with weight loss in general, is that most people regain the weight. That goes back to that set point theory, that our bodies want to be a certain weight, and so they're going to do a lot of things, regulate our appetite and our physical activity to try to maintain weight. So this is a really interesting study that was done. It was not originally designed to study a low-calorie diet, but this picture that you see, both of these are from the Biosphere 2, which is a facility that was built in Tucson, Arizona to study earth science. It really had nothing to do with weight, but what they did is they built this facility and they had people live in this closed system. They could not leave. They lived there for 2 years. These people were called biospherians. They were supposed to farm their own food and live off the land. And what happened is that didn't go very well. And so there was a very low food supply for these 2 years. And so these biospherians lost a large amount of weight. So it really became this natural experiment. What happens to your weight and your metabolic rate if you're exposed to almost starvation levels of food supply? So this is some of the data. They had some control subjects that they compared the biospherians to, so that's what you see here. This is 1 week after exit of the biosphere. Remember, they lived there 2 years. And this is 6 months after they exited. So you can see the difference in body weight is about 8 kilograms, so that's 18 pounds. Percent body fat. 1 week after exit, they had 10% body fat. 6 months after, they had 21% body fat. And then their metabolic rate, this is the really interesting piece, is that they burned 5,450 kilojoules per day. 6 months after exit, it increased another 400 kilojoules. So what we see is that exposure to this starvation level of food supply, not surprisingly, drops your body weight, drops your percent body fat, but it also drops the metabolic rate. So what it seemed like was happening is that their bodies realized, I'm basically starving, so I'm going to slow down this metabolic rate so that I don't burn off all of my own stores of excess fat and even muscle. And that's the response that we would expect, is that with starvation, your metabolic rate's going to slow down. There's another interesting study that was done at a clinical research center. This is a live-in facility where people would actually go. It's a hospital-like environment. They would go live at this facility to be in a research study. They were paid to do this. What they did is they gave them a liquid diet only. They calculated an amount that was sufficient to maintain a weight stable. They restricted their physical activity. And so what they wanted to do was see what happened to their metabolic rate. So here was the study design. They had 3 groups of subjects, people who they were at their maximum lifetime weight, as much as they'd ever weighed for at least 6 months, so their weight was stable at that weight, whatever it was. And then they matched those people to people who had recently lost weight, and they had lost at least 10% of their body weight for 5 to 8 weeks, and that loss came from consuming only 800 calories a day, liquid diet. So they're just consuming liquid, only 800 calories per day. Obviously they're going to lose weight, but they've maintained that weight loss for 5 to 8 weeks. And then they studied another group who had lost at least 10% of their body weight, but they'd maintained it for 1 to 6 years. So they want to compare these 3 groups to see what's going on with the metabolic rate. So here's their results. Total energy expenditure, each point is a participant, okay? This is the weight loss initial, so these are the people that they haven't lost any weight yet. They're at their maximum lifetime weight. These are the people who had recently lost weight. These are the people who had sustained their weight loss. So what you see is that this group has the highest total energy expenditure, meaning they're burning the most calories. And then your resting energy expenditure here, they all look fairly similar, but this group also has the highest resting energy expenditure. Then this is non-resting energy expenditure, meaning physical activity, really. So what this means, I think, is that losing weight, this group has lost weight, and this group has lost weight. Losing weight seems to lower your resting energy expenditure, or your metabolic rate. If your metabolic rate is lowered, what's going to happen? You're going to regain weight, most likely. So it seems like our bodies are basically set up, programmed in such a way that if we lose weight, our metabolic rate is going to drop to try to get that weight to come back. Really, I think God designed us this way to keep us from starving. Of course, we live in the United States in the 21st century where we're not at risk much of starving. Most people aren't. So this is a problem, and obesity is a problem. But originally we're designed this way so that if there's a food shortage, our metabolic rate slows down so that we don't die as quickly, basically. There's also a possibility that we would naturally reduce our physical activity. We may not think, okay, I'm not going to be as active today, but with weight loss, some research suggests that physical activity levels drop, and that would be similar to dropping our metabolic rate. So, does exercise and calorie restriction help people lose weight? Yes, of course it does, in the short term. But it's a more complicated question to say whether it helps them keep weight off long term. metabolic rate seems to drop with weight loss, at least in most people. Here is some data showing people who have lost weight. So they're called formerly obese, and that's these darker bars down here. This is showing the metabolic rate, a number of subjects with and their metabolic rate. So most of the subjects had a metabolic rate in here. A few had a metabolic rate that's a little lower. A few had a metabolic rate that's a little bit higher. And then the control subjects are these bars here, a little bit different color. So what this is showing basically is that the people who have lost weight, the formerly obese, have a lower metabolic rate than those who have not. People who are obese also tend to have a lower metabolic rate. And so the question is, does the weight loss cause the lower metabolic rate? And I think we've seen that yes, it does. So the other possibility is that there's some genetic factors that we're missing by just looking at averages. The other possibility is that the method of weight loss is important, and that's often not addressed in studies. So this group lost weight using what they call medical treatment. They used medicine and diet and exercise. And then the group on the right had bariatric surgery to lose weight, where their stomach was altered so that they physically cannot consume as many calories. So the metabolic rate in the group with the medical treatment was 2,338 calories before the treatment and 2,051 after. So their metabolic rate dropped, but it was not statistically significant. And if you look at the bariatric surgery group, their metabolic rate went from 2,434 kcals to 2,135. That was a significant decrease. So this suggests that the medical treatment group, something about the way they lost weight kept their metabolic rate from decreasing, whereas the bariatric surgery, it did result in a decreased metabolic rate. What this means is the way we lose weight might matter. Here's a study that suggests that to be true. It was related to exercise. So this study looked at participants who lost weight. They followed them at 42 months post weight loss. So 3.5 years after they lost a whole bunch of weight. And the sleeping metabolic rate dropped by 18.6% in the group who lost weight by dieting, and it dropped 9.8% in the group who lost weight by dieting and exercising. So this suggests that maybe exercise can prevent that drop in metabolic rate or make it a little bit less than just dieting. And the way it would do this is by preserving muscle mass or building muscle mass, because muscle is the tissue that actually burns calories. Fat is not a metabolically active tissue, meaning it doesn't use energy, but muscle does. And so if you have more muscle, you're going to be able to expend more energy. Another important question when we talk about weight loss and exercise is, does the intensity of the exercise matter? So here was a study. You have your control group here. They didn't lose any weight. This group lost weight by exercising at moderate intensity, and this group lost weight by exercising at high intensity. So the black bars are body weight, just your weight overall. The white bars are body fat, and the gray bar is fat-free mass or muscle. So the control group, there was no change in weight, fat, or muscle mass, which is what we would expect. The moderate intensity group lost weight, They lost body fat, and they gained a little bit of muscle mass, but not a lot. The high intensity group, they lost weight, not as much, but that makes sense because they gained muscle, and muscle weighs more than fat. They lost body fat, they lost body weight, and this is really important. They increased their muscle mass significantly. That's going to help prevent a drop in metabolic rate, and so high intensity exercise, according to this study, is going to be probably better at preserving metabolic rate, and therefore they're going to be more likely to keep off the weight that they lost. This is showing that same study, but how was energy expenditure or metabolic rate affected? So no change pre and post weight loss in the control group. The moderate group, their metabolic rate or their energy expenditure decreased, but in the high intensity group, their metabolic rate actually increased with weight loss. So high intensity exercise is a very important tool in weight loss because it seems to build muscle mass, and therefore metabolic rate doesn't drop as much. What about sedentary time? How is sedentary time related to obesity as compared to physical activity? Well, you're seeing odds ratios here, okay? And this is divided up by men and women. So the number of minutes per week of moderate to vigorous physical activity, MVPA, is what you're seeing here. So a high number of MVPA is the reference category. So doing a moderate amount of MVPA increases the risk of obesity by 1.62 times. And then a low number of minutes increases your odds even further. Those are similar for men and women. So that's not surprising. More minutes of physical activity protects you against obesity. Then TV minutes is kind of a proxy for sedentary time, and you can see that there is an increased odds of the more minutes of TV, the higher the risk of obesity, but the odds ratios are in the 1.5 range, so not a huge odds ratio. And if you look at sedentary minutes, the odds ratios do go up with more sedentary minutes, but not a whole lot, and actually none of those are statistically significant. So what this is showing is, again, according to this one study, physical activity is more important for obesity than. So in summary, obesity is a big problem in the United States. And we only talked about the United States, but it's a problem around the world as well. Weight loss is possible with calorie restriction and or exercise, but maintaining weight loss is much more difficult. You have to keep in mind metabolic rate and muscle mass. So exercise, including exercise in your weight loss, is very, very important, especially exercise that maintains and or builds muscle mass. That's going to keep the metabolic rate from dropping so much, and that's going to make it easier to maintain that weight loss. This week you have a quiz on Module 10, and then you will do Epi in the News number 5.